This is activity 3, translating a line. This is part 2. I decided to divide this activity up into 4 parts because there is a substantial amount of material that students have to understand or think about when going through this activity. So this second part is on 4 graphs, equations, and representations. And so here are 4 graphs, and here are 3 equations that go with these 4 graphs. Actually, there is a 4th equation which the student has to come up with on their own based on the graph that doesn't have an equation. And here are the representations. So there's 4 representations and the students have to match one of these representations with each of the graphs and the equations. So let's begin by just looking at the slope. Let's look at each of the graphs and find the slope. Now the dotted line is the proportional relationship that's then translated to the solid line. So you can begin with the proportional relationship and then this gets translated to the solid line. Begin with this proportional relationship, it gets translated to this solid line. Begin with this proportional relationship, translated to this one. And remember that these proportional relationships have the same slope as the solid line because they are translations. So you can use the proportional relationship to figure out the slope if you want. Doesn't really matter as long as you're keeping track of the change in the vertical change compared to the horizontal change. Doesn't matter which one you do. And I want to remind you that we're getting to this equation, this form, y equals mx plus b. Remember that m is going to be the slope, and you can think of that as moving. We'll go over that again. And the y-intercept, you can think of as the beginning amount. So when you translate this dotted line to the solid line, it's going to cross the y-axis. That's going to be the beginning amount. That's going to be the y-intercept each time. So you can actually read right off of the graphs what the y-intercept is before we even start. But we'll deal with the slope first. So a slope of 2, 2, 1/3, and then there's going to be a 4th slope. Okay, let's look at, this is graph number 1, this one up here in the upper left. And remember, you can use either the dotted line or the solid line to figure out the slope. Use the dotted line, you can just read the coordinates. This point right here has a coordinates of 2, 1. So an x value of 2 and a y value of 1. And so the slope is 1/2. It's just the y divided by x because it is a proportional relationship. Down here, notice that you can't just use the coordinates, but you can use the change, and that's what you should use, is the vertical change is 1 unit for a 2 units in the horizontal change. So once again, this is y over x equals 1/2, and you can just use the coordinates of this point right here to get that slope. It's also called the constant of proportionality because it's represents a proportional relationship. But down here, you have to look at the change. Now, this is good practice, and you should do this. This is good practice on adding and subtracting positive and negative numbers. So label the coordinates. The coordinates of this point right here are 2, -3. So the x value is first, that's 2, then -3. The coordinates of this point are 0, -4. So notice that's the y-intercept. You're not going any place on the x-axis, but you're going down 4 units. So it's going to cross the y-axis at -4. So that's going to be the b part of the equation. But for the horizontal change, that's these 2 units. It's gone over these 2 units, subtracting 0, because it's a 0 right here. So 2 minus 0 equals 2. You can just count them. These are 2 units, and the horizontal change is 2 units. The vertical change is, notice what happens here. This is -3 minus -4. Now remember what we were doing a little while ago. We're figuring out where it starts, and it starts at -4, and where it ends at -3. And then to figure out this change is the subtractions, the difference from where it ends minus or from where it starts. So it's a -3 minus a -4. So this is -3 minus a -4. Well, how do you subtract negatives? use the inverse operation, which is addition, and the additive inverse, which is a positive 4. So look what's going on here. So this is a negative 3 plus a positive 4. So what you're now doing is sliding this point up here 4 units up. And so now it's going to match this slope triangle up here. So you're sliding this point 4 units up. And so it's going to match this point right here. So now you can just read the y coordinate, and that tells you that's the change. That's why you slide this up here. Well, mathematically, that's what you're doing here. Negative 3 minus negative 4 is the same as negative 3 plus 4. So this has a vertical change of 1, horizontal change of 2, so it has the same slope, 1/2, and it has to. Vertical change is 1, horizontal change is 2, slope of 1/2. So which equation matches that? Well, none of them do. So that means this has to be the 4th equation. So you have to write, students have to write that on their own. So now you can start out y is equal to 1/2 x. This is the slope. This is the amount of x. We're eventually going to have to add where it crosses the y-axis. We know what that is already. It's negative 4, but we'll wait a while. We'll do that in a little while because right now we're focused on the slopes. So graph number 1 is going to go with equation D, and students are going to finish writing that. Graph number 2. So this is graph number 2. This is this graph right here. And if you go out 1 unit, it's useful to look at what the change is in the horizontal change. If it's convenient to look at it as 1 unit, then you can just read right off the graph what the change is, what the vertical change is. But this is a little bit tough in this case because it doesn't cross a grid line. So you go out 1 unit and you go up, and it's hard to tell how far this is going up. So alternatively, what you can do, or what you should do, is find a place where this graph intersects with the grid lines, both the horizontal and vertical grid lines. And the first place that happens is right here. So now the horizontal change is 3, and the vertical change is 1. And actually this point right here is 3, 1. It's an x value of 3, a y value of 1, so y over x is equal to 1/3. And so that makes sense. If you go out for 1 unit in the horizontal change, it's 1/3 of a unit in the vertical change. And that's what this is right here. This is 1/3. And you know that's true. This is 2/3, and this is 3/3 or 1. So you know that that is 1/3 here. This is 2/3 up, and this is 3/3, which is the same as 1. So for the solid line, now this is a translation up 1 unit. So now you can see what the y-intercept is going to be. That's going to be 1 for this equation, whatever this equation is. And the vertical change is this 1 unit right here. So 2, that 2 minus that 1. So we've gone up. We've moved this up 1 unit to here. So 2 minus this 1. So what are you doing when you subtract 1? You're moving this down. You're sliding this down 1 unit. So this length right here, this change, is just 2 minus 1 equals 1. And this change, since it's already against the y-axis, is just 3 minus 0 is 3. So the vertical change is 1 unit, and you can get that mathematically. Once again, 2 minus 1. So these are the y coordinates. 2 minus this 1 equals 1. And these are the x coordinates. 3 minus this 0 is 3. So the vertical change compared to the horizontal change is 1 to 3, or 1/3, which has to be the same as the dotted line because they are just translations of each other. They're parallel. They have the same slope. All right, so graph 2 goes with the equation that has a slope of 1/3. And that's this one right here. So this is graph 2, is C, goes with the equation that has a slope of 1/3. And notice what the vertical intercept is, or the y-intercept. It's 1. And we said that before. It's right. here. It doesn't look like it shows up in this image very well. It's right here. No, it's positive 1. It's right here. Oh, this 2 is hard to read, that's why. So this is 1 right here, this is 2, this is 3, and this is 4. All right, the next graph. This is graph 3. So we're now at this one right here, and notice where the y-intercept is. You're going to go down 1 unit, 2 units, 3 units. So this is going to be plus a negative 3 or minus a positive 3. And so we'll look at that in a moment. So if I use the dotted line, go over 1 unit, so a horizontal change of 1 unit, what's the change in the vertical change? In the vertical direction, it's 2 units. So 1, 2. So y over x is 2 over 1 is 2. And if you use the solid line, this vertical change is 2 units, the horizontal change is 1 unit. But let's look at that mathematically. This point right here is 1, 1. I'm sorry, 1, negative 1. So this is 1, negative 1. This point right here is 0, negative 3. So notice once again, this is the y-intercept. When x is 0, that means it hasn't moved either to the left or to the right. It's right on the y-axis, so you can just read right down here and see that the y-intercept is negative 3 when x is 0. So now you have to find the difference of negative 1 minus negative 3, because remember, this is starting at negative 3, it's ending at negative 1. So what's that difference? It's negative 1 minus a negative 3 equals 2. So notice what you're doing. Once again, you're sliding this up 3 units. 1, 2, 3. So you're adding 3. Minus a negative 3 is like adding 3. So this is going up 1, 2, 3. So it's going to match this slope triangle. And so the vertical change is these 2 units. The horizontal change is this 1 unit. The vertical change compared to the horizontal change is 2 to 1 or 2. So it has to match. This is the slope of 2. And this is a slope of 2. So which equation has a slope of 2? Well, we have 2 equations that have a slope of 2, both A and B. But equation B has a slope of, has a y-intercept of negative 3. So this is plus negative 3, which is the same as subtracting a positive 3. So if you look at the equation, this is subtracting a positive 3, which is the same as adding a negative 3. And I wish that at this point, right now, I wish they would use adding a negative 3, because that's what you're doing on this graph. You're adding negative 3. This is a negative 3. So you're adding that. So the equation that goes with graph 3 is equation B. Slope is 2. So it's 2x plus a negative 3. And they flip this over the equal sign. Doesn't really matter if you write it as y equals this amount with the y over here and this over here. It's the same thing. Okay, the last graph is graph 4. So we're going to go to this one. And in this case, if you go over 1 unit, notice this has half units marked off. So this grid line is 1/2 of a unit. And this grid line right here is 1/2 of a unit. So this is 1 unit over. How many units do you go up to get to the graph? You go up 1 unit, 2 units. So remember, you have to include the halves. So this is 1 unit, 2 units. So y over x is 2 over 1. So it's 2 units in the vertical direction, 1 unit in the horizontal direction. So this has a slope of 2, just has a constant proportionality of 2. And the solid line, so I'm taking a few shortcuts here just to show you how you're going to do this in the future. The solid line is 1 unit compared to 2 units in the vertical direction. So notice that the solid line crosses the y-axis at 3 halves. So you have to pay attention to what these grid lines, the value of these grid lines. This is 1/2 right here. This is 2 halves right here. And this is 3 halves. So the slope is 2. So for a horizontal change of 1, vertical change of 2, that's 2 over 1. That's a slope of 2. And the vertical intercept in this case is going to be 3/2. It crosses the y-axis at 3/2. When x is 0, y is 3/2. So which graph matches that? It has to be the one that's left, which is the y-intercept is 3/2 and the slope is 2. And again, they have written this where they've reversed the 2x. They've moved the 2x on this side of the addition symbol and the 3/2 on this side. It doesn't matter the order that you add them in, you get the same answer. So you can do that. You can switch their position over a addition symbol. So this is y equals 3/2 plus 2x. So graph 4 matches equation A. All right, so these are the 4 graphs and the 4 equations that match. And at the same time, I added this, adding a -4. So this is same as y equals 1/2 minus 4 right here, but you're really adding a -4. So that's the same as subtracting a +4 is the same as adding a -4. So this completes the 4th equation. We're going to need that to, and this is completing the 4th equation right here also. We're going to need that to match these representations. So let's look at this first one. So we're going to look at this one right here, which is 0 3/2, 0 3/2. So this is the table that we're looking at. So this is graph 4, which is equation A, because when x is 0, y is 3/2. That's telling you that it's crossing the y-axis when x is 0 at 3/2. Well, the graph that matches that and the equation that matches that is graph 4, equation A. Let's go back here a little bit. Graph 4, equation A. So this is graph 4. This is equation A. So it has a vertical intercept of 3/2 and a slope of 2. So let's pick up the slope for just a second. So the change from going from 0 to 1 along the x-axis, so you're moving along the x-axis from 0 to 1. That same change as on the y-axis is from 3/2 to 7/2. So that difference, 7/2 minus 3/2 is 4/2. That's equal to 2. So the vertical change is 2 units for a horizontal change of 1 unit. So that is a slope of 2. If I go from 1 to 11/4, it gets a little bit tougher. 11/4 is the same as 2 3/4. So I'm moving from 1 unit on the x-axis to 11/4 on the x-axis. That's 2 3/4. So the horizontal change is the difference of that. So 2 3/4 minus 4/4 is equal to 1 3/4. So just look at the 2, subtract the 1. That gives you the 1 3/4. And so how many total fourths is that? That is 7/4. So 4 times 1 is 4 fourths, plus 3 more fourths is 7/4. Lots of words. All right, so that same change is this change along the y-axis, going from 7/2 to 7. Well, 7/2 is 7 is the same as 14/2. So that difference, so this is where you end, this is where you start, so you have to subtract where you start from where you end. So 14/2 minus 7/2 equals 7/2. So that relationship, this is a change of 7/2, vertical change of 7/2, a horizontal change of 7/4. Well, 7/2 divided by 7/4, and this is why you should write this stuff out. It's good practice on working with fractions and just seeing what's going on. So 7/2 divided by 7/4. How are you going to solve that? Well, you're going to use the inverse operation, which is multiplication, and you're going to use the multiplicative inverse, which is 4/7. So you're going to multiply by the multiplicative inverse or by the reciprocal. So 7/2 times 4/7 is equal to, the 7's cancel out. You're left with 4/2, and 4 divided by 2 is 2, or you can factor them out and cancel. So 2 times 2 over 2 times 1, these 2's cancel, you're left with this 2. All right, this is the second table. So do this a little bit faster. The change, the y-intercept is -4, because when x is 0, you haven't gone anywhere on the x-axis, but you've gone 4 units down in -4. So this, you might remember that that's equation D and graph 1, if you look at those 4 graphs and 4 equations together. So what's the change? So if you change 2 units along the horizontal axis, so you've gone 2 units to the right, how far have you gone either up or down? We've gone from -4 to -3. So that's a start at -4, you're ending at -3, so that's a 1 unit up. -3 minus a -4 is the same as -3 plus 4, and that is equal to +1. So the vertical change is 1 unit, the horizontal change is 2 units, so the slope then is 1/2. So you have a y-intercept of -4 and a slope of 1/2, and again, that is equation D if you go back and look. The y-coordinate is 3 less than double the x-coordinate. So these are always kind of tongue twisters, hard to follow. You just have to write out exactly what it says. So the y-coordinate, so you have an x value and a y value. That y value is called the y-coordinate. That coordinate is 3 less than double the x-coordinate. So write down what double the x-coordinate is. That's 2x. That's 2 times the x-coordinate. And then what's this 3 less mean? It means that you're going to take twice the x-coordinate, whatever the x-coordinate is, the number for that point in the x position. You're going to double it, and you're going to subtract 3. That's going to tell you what the coordinate is for y. And this is the equation. That's what the equation tells you. If I have an x-coordinate of some value, what is the y-coordinate? Well, you take that x-coordinate, you double it, and then you subtract 3. So if the x-coordinate is 2, 2 times 2 is 4, 4 minus 3 is 1. So this point would be at 2, 1. And so that's graph 3, equation B. Let's see if I put this in here anywhere. So graph 3, equation B. Graph 3, equation B. Graph 3, equation B. So this one right here. So you double the x-coordinate and you subtract 3. So it's 3 less than double the x-coordinate. So if you go out, I can't find this. Sorry about this. It's right here. So I just said, I use as an example 2. If x is 2, you double 2. That's 4. Subtract 3 from 4, and you get a y value of 1. So this point right here is going to be, the coordinates for this point are going to be 2, 1, as an example. Takes lots of practice. All right, and the last one, the slope is 1/3. So that means it's 1/3 times whatever the coordinate of x is. And the line goes through the point 5 8/3. So it goes to the point 5 8/3. So this one's tough because you can look at the graph, you can find which graph matches that, and then write the equation for that. And I think that's the way they expect you to do this. And so that matches graph 2. So if you go to graph 2, you're going to see that the slope is 1/3. So for a horizontal change of 3 units, the vertical change is just 1 unit. And if you follow that line on graph 2, equation C, so graph 2, equation C, graph 2, equation C, if you follow that line over to 5, then the y-coordinate is 8/5. So this is, that's hard to tell. This is 5/5, and this is another 3/5 to 8/5. It's hard to read that. I'm sorry, up here. This is 5, oh no. Oh, 8/3, sorry. So this is 5, this is 8/3. So 8/3 is 2 and 1/3. So let me go back. Sorry about this. So this point you go out to 5, and this is 8/3. So that's 2, 1, 2. Oh, I'm sorry. 8/3 is making a mess of this. 8/3 is 2, and this is an example of what you should go through as students. 8/3 is 2 and 2/3. Now I knew it wasn't making sense because this is more than 1/3. It's actually 2/3. So you go to this point, 5 and 8/3, which is 2 and 2/3, and you get right there. So this matches graph 2. This is equation C, graph 2. Sorry about that. Kind of making a mess of this. And what you can do is plug in, it's giving you the value of y, which is 8/3, and that's equal to 5/3, which is the value of x, plus b. So 8/3, y is equal to, now this 5/3 is 1/3 of 5. So it's, the x value is 5, 1/3 of 5 is 5/3. That's where I'm getting the 5/3 from. And then you add b to that, whatever b is. Well, 8/3, and you have to subtract this 5/3. 8/3 minus 5/3 is equal to 3/3. 3/3 is equal to b, so the y-intercept is equal to 1. So the equation becomes y equals 1/3 x. They tell you that, plus the y-intercept, which is 1. Sorry about that, kind of made a mess of this. But again, it's messy thinking about this stuff. It's tough to go through this stuff and think clearly about it. So this is graph 2, equation C. Tough stuff.